Recently, I had the opportunity to interview Dr. Ioannis Michaloudis, an artist, academic, and researcher who recently collaborated with Coperni to debut a bag that is made from the same materials that NASA uses to capture stardust. For those who don't know, Coperni is a French fashion luxury brand known for their avant-garde designs and their experimentation with emerging technology. One of the brand's most memorable and viral moments was when they spray painted a dress onto Bella Hadid on the runway. Now, a design that they're known for is called the Swipe bag, and it's actually inspired by the swipe to unlock icon on your iPhone, so you can already start to see the connection between fashion and technology when it comes to Coperni. For their fall collection, Coperni presented an otherworldly and intergalactic runway show, and during that show they debuted the Air Swipe bag, a version of the Swipe bag made from the same materials used to capture stardust. The bag is 99% air and 1% silica, yet it's strong enough to hold lava. I spoke with Dr. Michaloudis, who has a background in textile design and who has collaborated with NASA on the creation of the Coperni bag and why we should look to space technology for inspiration to design the materials of the future. It's an interesting conversation and it starts right now. But tell us about aerogel. As I understand, it's made of 99% air.
Exactly, nothing. 99% nothing is worse. So I made this nanomaterial. Nanomaterial means very tiny particles, okay, very tiny particles, invisible to the eye. I made it at MIT when I was there for my postdoc, and I found it very beautiful. It is beautiful. It is blue with black background. I have it here. If you want, I can show you.
Yeah.
Blue with black background, and we can describe it with for the listeners also. So it is. If I put it in front of my shirt that is dark, it looks blue. But if I put it on the background that is clear, it looks transparent. And this is not all. Only it is solid. It's the lightest solid in the world. You can see through. It looks like frozen smoke. Its nickname in NASA is frozen smoke. But I found it as a personification of our sky. And because we are in a very crazy moment with the climate, I found that it will be a good metaphor to speak about the sky, the last garment of our planet, to speak using this material as a personification of nothingness, of air, of the sky also. And also it is a personification for the artist himself or herself, because we think about artists that they are very delicate, but they can change the world. How you can see, for example, let's say, painting after Picasso, or sculpture after, or mechanics after Leonardo da Vinci. This is how delicate, but can change also the world. That's how I like silica aerogel. There are many aerogels. Aerogels means that you have gel and air inside. And here we have 99% air and arrive at 99% nothing, and 1% glass because it's silica. So you are working with nothingness. You are molding nothingness. That's the amazing thing.
It's so amazing, and pardon me, it's so amazing, and it has this kind of ethereal quality to it because of the translucent nature to it. You said it's called frozen smoke, which I love. As I understand it, the material was originally made to capture stardust in space.
That's correct. That's correct. The material itself, it was discovered 1937, very many years ago. It was a bet between chemical engineers. We don't have Nobel Prizes at this moment. We had bets, So the chemical engineers, they bet that they can make a gel that they can dry it without trinkets. Look at this one. I have another bottle here. I can describe it. This is the silica aerogel is inside the bottle, and when I drop it upside down, it drops, but there is no shrinkage at all. You see?
So is it a solid or is it liquid?
It is solid. It is solid.
It's a solid.
It is a solid. Yeah, you can push it. Yeah, with your finger. Look at this. You can push it up.
Oh my goodness.
It goes down. And this was the bet. The bet was to make something that when you dry it, it doesn't shrink at all. So this is the that has how it started, the Stanford University. And in our days, around end of this century, when I was at MIT, I learned that NASA is using that for stardust capsule. It looks amazing. It looks like a mythological. Somebody's going to capture stardust. Anyway, I found that amazing, and I learned about that. It can withstand a lot of heat. It is a safe energy material. That's why I was invited to ARPA. We will speak about that later, to the Energy Summit, because it's an energy saving material. And probably the energy of the future is not creating more and more energy, but saving energy. That's what my idea there.
And so, where do I place this material in the spectrum of material science? So, in material science, like, we've heard a lot about biotechnology, for example. So, materials that are made from mushrooms, let's say, and cultivated. You called it nanotechnology or nanomaterial. So, it's particles that are invisible to the human eye. But
Exactly.
how do you make something of it if you can't see it? It's like a designer making an invisible dress.
Nice option. The materials from now on, they will be nanomaterials, because in nanoscale you can control the qualities of the material. So you can control the size of the shape of the particles, and that's why you control the color or the qualities, the thermal qualities or the mechanical qualities. And here, fashion has a huge lesson to learn, that materials from now on are not only textile materials. They are coming from all over the material science, and especially the space technology, because there they test the materials to extreme conditions. So if they are tested to extreme conditions, they are very good for Earth application. And because textile is one of the most innovative industries, and fashion also, they are, let's say, precursors for the society. That's why textile design and fashion design, they will take these materials to be applied. This is a silica. We know glass. Glass is silica. Okay, we apply glass everywhere. This is a form of glass, solidified form of glass. So it is glass again, but it is nano form of glass. It is the glass of the future.
So does it decompose then? Because one of the big
Yes,
conversations in fashion is this idea of sustainability and materials. A lot of the materials that are on the market today are made with materials that won't ever dissolve, and that's causing a huge problem for the planet. So
yes,
silica, I mean, it might not be the best material for, something you'd wear on your body. It might fit something more like a purse, but it would dissolve in the end.
exactly. If you leave it outside, and after normally it will dissolve, it will never dissolve, because it's the best glass in the world. It's like a glass sculpture. But
Hmm.
if you leave it without, let's say, protection, then it will dissolve from the environmental conditions, rain, air, snow. So it will dissolve with powder of silica.
And so, if the bag is made of this kind of biodegradable material, it's kind of there and not there. You've made a purse out of it. Does it actually hold anything that you would normally put in a purse, like a phone or
That
your
that is,
keys?
that was the big question. When we decided to go ahead with the project, I saw the dimensions of the iconic bag and the thickness of the bag. It was not ideal for the drying, because when you make the aerogel, you have to create an alcohol gel first, alcohol with the chemical, and then you have to dry out the solvent. But when you dry it out, if it is too thick, then it will never dry. It will stay with a cloud in the middle, and this cloud will be humidity. You don't want this kind
Okay.
of cloud. That's why I proposed to Sebastian and his team, and they accepted immediately, to put a pocket there. So to have an empty space, so it will dry more easily. So these pockets make the big deal to the comments afterwards. What we can carry with this project, everything. But I believe that it was a huge success. Thanks also to the character of Coperni, the researcher character of Coperni, but also thanks to this pocket, because I put inside the pocket an iPhone, an old iPhone that I had in my lab, 4S, and because and thanks to this, people they were reacted very. So to see something very airy, to hover something that you know very well, it breaks your limits. It breaks your way of perceiving the world. And there it starts the questions. There starts the art. You say here it is something that I don't understand. I don't believe, and then you start investigating more. Even melted brass. Imagine
Wow.
you can carry lava in the pocket of Coperni Bag.
And that's due to the aerogel's
Insula-
heat resistance, right? That's why it
exactly,
can go to space. That's why
exactly.
it can be used in these different applications. So you can actually carry a liquid around you. Not that that would be very practical,
And
but fashion itself is not very practical sometimes, especially when you're thinking about couture. You know, you see handbags that are so small that you couldn't fit a phone in it anyways. So it's really not that far of a stretch. But I'm very interested in when things go from this conception to implementation in the industry. Is there
exactly.
room for aerogel to make its way into modern materials that we would maybe purchase on the high street or at our local retail department, or are we too far away from that?
I believe because it's laboratory research and it's very expensive, I believe it has to be for luxury product like the Coperni bag or the Boucheron necklace that we made 2 years ago. But what is the silica aerosol? It's like a manifest. It manifests our need of a clean sky. The sky is the last garment of our planet. If we destroy the sky, then our planet will be destroyed. And this is where the Coperni bag, even without knowing, it has a meaning. It is manifesting our need about the climate change and about clean energy, probably, from now on.
Yeah, I love that. I love that idea of the metaphor of the planet's last garment. I think that's really beautiful. Now,
Exactly.
you are someone who has worked with NASA for a long time. It seems you have a very scientific background, but you're very creative as well. So in a way, you kind of embody a little bit of a contradiction because we think of tech people and fashion people as often very opposites. But tell me about your work with NASA and if you've ever done anything in the fashion space before.
Yes, my background is textile design first. My bachelor was in textile design. Then I made my diploma in Paris in fashion design. Then I did fashion design, and then I went to arts and then to science. I am not even an artist. I am not a scientist. I am in between. There
Mm-hmm.
was Henri Poincaré, the same period that Picasso had started the Cubism, and Picasso was inspired by Poincaré. He was mathematician by Poincaré, and he was saying something that even an artist could not believe. He said that in between, there are dimensions in between dimensions. Between 2D and 3D and 4D, there are other dimensions that we cannot measure yet. So I believe that this kind of ethereal material and probably my approach is in between science and art. Is neither art, neither science. And industrialization had created labels. You are an artist, you are a scientist, but before, imagine Leonardo, he was a universal human being. He could create canons in the same time that he could create Mona Lisa. So it is up the human mind, and especially you see it in kids. The kids they are not specialized. They play with everything, and I believe that if we continue this kind of kid methodology of in everything we are doing, then we will create our personal mythology. And mine is methodology. I take from mythology, I take from methodology, and I create my own let's say, osmosis, my own synergies in that.
Yeah, and I think there's a lot that the fashion industry can learn from that because they're very set in their ways of production. It's got to be done this way, and you have a certain amount of lead times and four shows a year, and these materials, these manufacturers, it's very structured, and it's structured that way because, as you said, industrialization, but also efficiencies, right? And so
Exactly,
when
and
you throw a
money, and
material,
money, and
exactly.
money. They are
Money.
running after money. This is the problem. This is the problem. Not only fashion, but all industries, they have to rethink about how we get money. We get money for ourselves or for also by providing services to others. Fast fashion, for example, it was a big error, and it is a big error still. So we have to reconsider our society.
Yeah, absolutely. And so you talked a little bit about how the relationship with Coperni came up. You heard that they were looking for somebody to work with this material. You had familiarity with this material, and you said there was just a couple months lead time between when you got the call to create this bag and when it actually showed on the runway. What was it like in that process?
Exactly.
And then finally
It's a
seeing
very
it.
nice collaboration story because I like the team of Coperni, and I advise my students because I teach design now. I am the dean of the Faculty of Arts and Humanities in American University here in Cyprus. And what I advise my students is, to work as artists. In design, you have to work as a team. And what I found with Coperni, they are working as a team. And sometimes I found that they are not working as a traditional fashion team after they are running after their tail, we can say. They think about that. They decide about that. So when we started and I had a command, for me it was a command, okay? It is a command. We want this same in this material. Can you make it in 90 days? Very clear command. Then it is up to you to see if it is possible because you know the limits of the material, the limits of the time. You are not working only on that. You have also your teaching, and this you have to combine all that. To my team and my students and to all my colleagues, we found that it is possible after 9 non-successful trials, because you need a lot of chemicals. This aerogel, it was the biggest volume ever that was created with this nanomaterial. It is visible, the nanomateriality, because you see it blue. I have it here. If you want, I can show you
Yeah, let's see.
how it looks here. And we see here some samples, a sample of aerogel of the air side bag, like that I presented in ARPA in United States last May. Here it is.
Wow.
It is, yeah, wait a minute, I will go back to, so it is
Yeah,
blue,
beautiful.
and when it goes to one out, you disappears, but then the transparency is
Yeah,
here.
so it almost takes on the quality of whatever it's up against. If you're wearing a pink dress, it's going to look pink. If you're wearing a green dress, it's going to look green. But then it
It
has
is
this like
transparent. Yes,
smokiness to it, the smoky quality. And it almost looks
exactly,
like something that should be liquid has been frozen in time.
exactly,
And in
exactly.
that way, it's kind of like a moment. And it was also a moment on the runway at
It
Paris
was a
Fashion
very
Week.
beautiful moment because Leo Dan, he's a very professional model. He created a nice presentation of the object, and the airside bag was final effects also with him because he had a very straight. Of course, he had some directions about that, but he had a very good presentation. And I believe that all the 90 days of work, they were at the moment of when Vogue came and filmed the back that you have seen in the Coperni studio. And it was an all moment for the team, but also for me to see that this will go forward. It was a day before the catwalk, so we had only 24 hours to test it and present it.
Yeah, it's always so funny that you see the very polished look on the runway, and then all of the work that went into it is kind of behind the scenes, like the 9 failed bags or the scraps of fabric on the cutting room floor. Like you don't see that. As I said, you're this person who's working at a really interesting intersection, and I'd love to know, in your mind, the connection between space exploration and fashion. You kind of alluded to it before with this idea of the ozone being the last layer of our Earth. But what else do you see? I mean, I when I think of space and fashion, I think, of course, of Playtex and how they made the first astronaut suit to go to the moon, and it's this hidden relationship really with advancing materials and the fashion industry. I'd love to know from your perspective, as someone who's been working
Yes,
in both.
as I told you, the textile and fashion, they have to be inspired by space technology, and space technology is the future of our humanity. So if we want to follow what is, let's say, wearable fashion, or sorry, wearable technology, all these materials are space technology materials. So how you include sensors to your garments, or what kind of sensors will be that you can wash also your wearable technology, or you can have it as a bag. This is all this can. That's why I believe that collaborations between scientists, artists, technical staff, that they know about space technology, that has to continue and has to inspire from now on, not in the plastic, let's say, polluting way, but in the concept way, and also to how to create something that it is good for the humanity. Not something that is good for my pocket, but it is something good for the humanity. And here is the big leap that we have to make, is to think about the others.
And why do you think it's happening now? Is it because of the advancements in nanomaterials?
Yes, not only for that, because we are obliged to go to the space. We are overpopulated, and we need to move to other planets. If we are lucky enough to find a solution with the climate, very fast solution with the climate, and the solution isn't coming from the others, coming from ourselves, to a little bit change our attitudes towards everything. What we are eating, for what reason we are eating this one, what kind of garments we are wearing, then our planet probably will keep his last garment, the sky, for longer. So if we, I believe that we have to move to other planets, but in the same time, we will be here, like it was European and then Americans and now Australians. We will be Martians in the moon and everything. That's why we have this kind of urgency of going ahead. And this urgency obliges us also to have good and new technologies that they will be applied also in society. You know, a scientist that has no application his result of research, so they don't get a lot of funding. So when you have somebody, that's why the scientists, they like my research, because I show to the society that it is not only for papers and scientific results, but it is also for society.
Yeah. Yeah, I think it's really important, the work that you're doing, and I thank you so much for taking the time to speak to me and our audience today about it. How can people follow your work and stay in touch with you?
Instagram, Ioannis Michaloudis, or Michaloudis.Ioannis. Probably you have a test both. My
We'll
name
put the link in
with a
the
dot.
description. We'll put the
Yes,
link
I
in the
will put the
description
link.
so people can
Exactly.
follow you in the show notes. Thank you so much for your time. I really appreciate it. It's fascinating work. It's definitely a viral moment in fashion. Yeah, your commentary just helps me understand where we're heading so much more. So thank you for that.
Thank you, Amanda.